Perhaps one of the biggest milestones in the development of mankind is the invention of transistors, and we are not that aware of it. Let's look at all the developments around us in the last century. Computers, the internet, airplanes, smart home appliances, artificial intelligence, even space travel. All this was actually made possible by just one invention. Here is our little hero, the transistor. When the first computers were invented, they were really big. They could take up rooms and weighed tons. Isn't it amazing where we are now? They fit in the palm of our hands. We even wear them on our wrists, all thanks to transistors. So what are these transistors? So what is the secret behind all these developments? Quantum physics. Yes, you didn't hear wrong. Quantum physics, which may sound complicated to some, has given us these gifts. How? Let's examine it together. Transistors are a circuit element with emitter base and collector legs, and its internal structure is as shown in the figure. Transistors are actually the simplest definition of three semiconductor materials joined together. So if you say, what is a semiconductor? We can say substances that can be both conductive and insulating. One of the most efficient semiconductors is the silicon atom. At this point, let's move to the atomic dimension for better understanding. Atoms, as you can usually see, are made up of a nucleus in the center and electrons orbiting around the outside. And in their normal state, atoms have equal positive and negative charges. Also, the behavior of all atoms tends to be stable. In this tendency, known as the octet rule, all atoms except the helium atom hold 8 electrons in their outermost orbit. Occasionally, electrons in the outermost valence orbital can become detached and free. An electron can escape from its own atom and move into the atom of a conducting substance. This movement of electrons is called electric current. The silicon atom has 4 electrons in the outermost orbital, but it forms covalent bonds by sharing electrons with neighboring silicon atoms, obeys the octet rule, and passes into a stable structure. In this state, there is no electron movement and it is insulating. But if an extra substance is added, we call it P or N-type doping, silicon turns into a conductive material. That's why we call it a semiconductor. This is how NPN or PNP transistors are created. Let's see what happens if we add a phosphorus atom between the silicon atoms. The phosphorus atom has 5 electrons in its outermost orbit. When we add phosphorus to silicon, it starts to replace some silicon atoms. When the structure in the figure is formed, the atoms will have the 8 electrons they want and will not need the 9th electron. This means that the electron can move freely. This is type N doping. Now let's add an aluminum atom. There are only 3 electrons in the outermost orbital of aluminum, and when we create the same structure as before, the stable structure with 8 electrons will not be formed because there are not enough electrons. This is type P doping. So, what happens if we combine these two materials? First of all, some of the excess electrons of type N will want to move to the vacancies of type P. But after this first movement, the movement stops and a barrier is formed and we get a potential difference. At this point, an electric energy greater than this potential difference that will be given to the system will perpetuate the electron movement, and the electrons will continue to move in only one direction without stopping. This is a diode. But if we now insert another doped silicon into the system, we get a transistor. This is how electrons are represented in transistors. If we send an electrical signal to the base leg in this way, even a tiny one, we make the system work. Let's imagine that we normally turn a simple circuit on and off. Imagine that the open state is 0 and the closed state is 1. In the same way, when we apply a current to the base leg of the transistor, we will initiate the movement of electrons and create the same 1 and 0 state, but this time at very high speeds. This is where the power and importance of the silicon atom comes from. Now you have figured out where the name Silicon Valley comes from. it is useful to point out here. In fact, computers do not understand the numbers 1 and 0. They see the voltage value with the opening of the transistors and do not see voltage with the closing. We humans call these processes 1 and 0 to better characterize this situation. The operating systems and protocols in the computer enable computers to perform certain operations at very high speeds with these 1s and 0s. For example, when you press the A key on the keyboard, the signal determined according to the ASCII protocol goes to your computer's processor. The processor interprets these signals and sends a signal to the LEDs in the pixels of your screen with another protocol, and the letter A is formed on your screen. Of course, this happens at the speed of light, but billions of transistors in our processor work simultaneously, allowing our computer to perform many operations at the same time. For transistors to become what they are today, it was not easy for room-sized computers to enter our homes. Robert Noyce invented the first integrated circuit using silicon and founded the Intel Corporation with Gordon Moore. Both of them are physicists, and much of what is described in this video is based on the science of physics. In fact, we owe most of the electronics, artificial intelligence, computers, telephones, and other things that make our lives easier to physics. While the number of transistors in integrated circuits was around 1,000 in the 70s, this number reached 1 million in the 80s and 50 million in the 90s. In an iPhone 7, this number has reached over 2 billion. This increasing number of transistors has brought us this advanced computer age. But there is a problem. Transistors have become so small and microscopic that we have reached the limit for the free movement of electrons. So is mankind going to stop here? Of course not. This leads us to quantum computers, neuroformatics programming, and many more. Because every new wall we encounter means that we will break through it because of our desire to discover what's behind it. This is why science is so important for mankind. If you liked the video, don't forget to press the like button and subscribe to the channel.